Welcome to the deep dive. This is where we take your sources, articles, research notes, all that stuff, and really boil them down.
You extract the key insights, give you that shortcut to being genuinely well-informed.
Exactly. And today, we're diving deep into stories of scientific persistence.
Oh, this is a great topic.
It really is. The core idea we're exploring is that, many big scientific breakthroughs, they weren't just luck, not just a flash of genius.
Right. More often, it was decades of work,
Hmm.
relentless questioning, tons of experiment.
And often, battling some serious opposition.
Definitely.
So we're going on a bit of a journey here. We'll look at some truly remarkable people: Galileo, Newton, Marie Curie, Enrico Fermi, Stephen Hawking, and Hideki Yukawa.
A fantastic lineup.
Yeah, and you're going to see how their sheer curiosity and determination really fueled everything.
Unshakable determination in many cases.
Totally. So our mission for you today is to show how these minds just forged ahead, despite doubt, despite dogma, even serious illness.
And why these stories still matter so much today.
Exactly. Okay, let's unpack this.
Let's do it.
We have to start with Galileo Galilei, right?
Mhm.
Born February 15th, 1564, a foundational rebel, you could say.
Absolutely. He fundamentally changed how we see the universe.
And his persistence was so practical. I mean, he didn't just get a telescope.
No, he made his own.
Right. And kept improving it, up to 30 times magnification, which is pretty amazing for back then.
Incredible. And with those tools.
He looked up, saw the moon's craters, Jupiter's big moons, the 4 Galilean moons we call them now.
Saw Venus's phases, even sunspots.
And every single one of those observations, one after the other, it just chipped away at the old model.
The geocentric model. Earth at the center.
Yeah, that model, his observations just didn't fit.
And then came his book, Sidereus Nuncius, the Starry Messenger, in 1610. That really lit the fuse, didn't it?
Oh, definitely. It sparked wonder, for sure, but also
Very flicked. Big time. With the established powers, the church mainly.
it escalated pretty quickly from just, wariness to actual formal condemnation.
Yeah, leading to his trial in 1633. He was forced to recant, to say he was wrong,
Even though he knew he wasn't.
and then placed under house arrest for the rest of his life.
But here's where it gets really interesting, I think. Despite being confined, basically silenced,
His spirit just wasn't broken.
not at all. He manages to publish discourses and mathematical demonstrations relating to 2 new sciences in 1638 from house arrest.
Which is just incredible resilience. And that book was hugely significant, wasn't it?
Monumental. Tell us a bit about why.
Well, in it, he laid out the law of falling bodies, how things accelerate under gravity, regardless of their weight, essentially.
Cornerstone of physics.
Exactly. And maybe even more importantly, he helped formalize the scientific method itself. Observation, experimentation, mathematical analysis.
So even locked away, he's laying the groundwork for the future.
Precisely. It shows that persistence isn't just about doing the work, but making sure the ideas survive. That final book became like a blueprint for the next revolution.
It's amazing. Proving intellectual freedom can kind of transcend physical walls.
A powerful lesson, yeah.
And that legacy, that torch of persistent inquiry, it feels like it was passed almost directly because Isaac Newton,
Born in 1642.
the very year Galileo died, it's almost symbolic, isn't it?
It really is. And Newton, another giant, obviously.
He builds on those foundations. His laws of motion, universal gravitation, synthesizing centuries of work.
He himself said it right, standing on the shoulders of giants. Galileo was certainly one of those giants.
Definitely. But what was Newton's unique spark of persistence, do you think? What let him connect the dots?
Well, his analytical power was just immense. But I think it was also his ability to hold a question in his mind for years.
Like the Apple story.
Yeah, the classic story.
Yeah.
Grasping that the force pulling that apple down is the same force keeping the moon in orbit. That leap.
Connecting the earthly and the heavenly. It seems obvious now, maybe, but it was revolutionary.
Absolutely. And remember the context. He did some of his most profound work during periods of plague, political chaos, isolation.
Right. During the Great Plague, he retreated to his family farm and had this incredibly productive period.
He just kept thinking, kept calculating. That analytical persistence is key.
And the result was his Principia Mathematica in 1687.
Philosophia and Naturalis Principia Mathematica.
Yeah.
A mouthful, but it fundamentally reshaped physics. It really fueled the Enlightenment.
How would you describe his approach?
Is this powerful mix, careful observation, absolute mathematical rigor, and just this fierce, driving curiosity.
Einstein apparently praised him, saying something like, "Nature is pleased with simplicity."
And nature is no dummy.
Yeah.
Newton's genius was partly in finding that elegant simplicity in the complexity of the universe.
His persistence wasn't just against external stuff like the plague, but in that relentless intellectual integration.
Exactly. Integrating observations, math, existing ideas into this grand structure. It's a testament to that kind of deep, focused persistence.
Okay, let's jump forward now. Late 1800s. Marie Curie, born Maria Sklodowska in 1867.
An incredible story. The obstacles she faced right from the start were huge.
Yeah, poverty, the sexism of the time, which was intense.
And political turmoil in Poland under Russian rule, which limited opportunities, especially for women.
Which is why she moved to Paris in 1891, right, to study at the Sorbonne.
Yes. And there, her quest really began.
Yeah.
Understanding this new phenomenon, radioactivity, discovered by Becquerel.
Working alongside her husband, Pierre Curie.
Under really difficult conditions. We're talking poorly equipped labs, basically sheds.
And dealing with materials that, unbeknownst to them initially, were incredibly dangerous.
Yeah, the constant deadly exposure to radiation, plus that relentless skepticism from the scientific establishment, which was overwhelmingly male.
It's hard to even imagine the layers of difficulty, yet her achievements.
Wow, groundbreaking is almost an understatement.
First Nobel Prize in Physics, 1903, shared with Pierre and Becquerel.
For their work on radioactivity.
And then she wins another one, chemistry, 1911. All on her own this time.
Making her the first person and still the only woman to win Nobels in two different scientific fields. It's just extraordinary.
What did those prizes really signify back then?
They were hugely significant. She didn't just study radioactivity. She identified two new elements, polonium and radium.
Named polonium after Poland, right?
Exactly, a nod to her homeland.
Mm-hmm.
And she deeply explored radioactive decay, how these elements spontaneously change and release energy.
Her work really opened up a whole new field of physics and chemistry.
And her sheer tenacity, her persistence, despite the sexism, the poor conditions, the danger, it fundamentally changed the game for women in science.
She showed it could be done.
Yes. Her dedication continued right up until her death in 1934,
Yeah.
likely from plastic anemia caused by all that radiation exposure.
Her famous quote comes to mind, "Nothing in life is to be feared, only understood."
Perfectly encapsulates her spirit, doesn't it?
Uh.
Facing the unknown, including the dangers, with a drive to understand rather than shrink back. Her life is a profound lesson in courage and intellectual focus.
Truly. Okay, let's shift focus again. Enrico Fermi, born 1901 in Rome.
Ah, Fermi. A unique figure, a master of both theoretical and experimental physics, which is quite rare.
A prodigy, really. But he faced challenges too. He had to leave Italy.
Yes, he immigrated to the U.S. in 1938. His wife was Jewish, and Mussolini's fascist regime had enacted anti-Semitic laws barring Jewish people from academic positions, so they left.
And he ended up playing a absolutely crucial role in the U.S.
Pivotal, especially in the University of Chicago. In 1942, he led the team that achieved the world's first controlled, self-sustaining nuclear chain reaction.
And the setting. It's almost comical if it weren't so serious.
Under the stands of a disused squash court at the university. Chicago Pile 1, it was called.
Incredible. A turning point in history happening under a stadium.
It really was, and that led to him becoming a key figure in the Manhattan Project by 1945.
Building the atomic bomb. But his persistence didn't stop after the war, did it?
Not at all. He became the Swift Professor of Physics at Chicago, a really prestigious position. He was instrumental in advancing nuclear reactor design at Argonne National Lab just outside Chicago.
Focusing more on peaceful applications.
Yes, and also fundamental research, exploring things like neutron scattering. His influence was immense. He mentored many students who became top physicists.
And you mentioned he laid groundwork for women scientists, too.
Yes, people like Maria Goeppert-Mayer, who worked in related fields and later won the Nobel Prize herself. Fermi fostered an environment where talent could thrive.
So his persistence was in the science itself, but also in navigating the ethical complexities and building for the future.
Exactly. He represents that bridge between pure discovery and real-world application, grappling with the immense power science had unlocked and trying to guide it responsibly. That requires a different kind of persistence, navigating societal impact.
A very different challenge. Now let's talk about someone many people feel they know. Stephen Hawking, born 1942.
An icon, really, and his story is inseparable from the immense adversity he faced.
Diagnosed with ALS, motor neuron disease, at just 21, doctors gave him only a few years to live.
A devastating prognosis for anyone. let alone a bright young physicist just starting out.
But he just refused to be limited by it. He defied all expectations, living for decades longer.
And not just living, but revolutionizing cosmology. Spending decades unraveling the deepest mysteries of black holes, the origin of the universe, the nature of time itself.
His most famous work, perhaps, showed that black holes aren't entirely black.
Right, Hawking radiation. His groundbreaking insight was that, due to quantum effects near the event horizon, black holes should actually radiate particles and slowly evaporate over immense timescales.
Which was stunning because it brought together Einstein's general relativity, describing gravity and black holes.
With quantum mechanics, the physics of the very small, a unification many physicists dreamed of, that was Hawking's genius.
And here's the truly astounding part for me. As his physical condition deteriorated, eventually losing his ability to speak,
He continued, using assistive technology, that famous computer voice.
he kept publishing cutting-edge research, writing books, giving lectures, engaging with the public.
He absolutely turned adversity into aspiration. His book, A Brief History of Time, published in 1988,
Became a massive global bestseller.
made these incredibly complex ideas about the cosmos accessible to millions. He brought theoretical physics into popular culture, like few others.
His persistence wasn't just scientific, it was existential. A triumph of mind over matter in the most profound sense.
Absolutely. It demonstrates that intellectual curiosity, the drive to understand, can be powerful enough to overcome even the most daunting physical limitations. An inspiration, truly.
Okay, our final story takes us to Japan. Hideki Yukawa, born 1907 in Tokyo.
Yukawa holds a very special place. He was the first Japanese scientist to win a Nobel Prize in physics.
Which he received in 1949. What was his key contribution?
His persistence was in theoretical rigor. Working at the University of Kyoto in the 1930s, he tackled a major puzzle: what holds the atomic nucleus together?
Protons are positively charged, they should repel each other. So what keeps them packed in the nucleus?
Exactly. Yukawa hypothesized a new particle, heavier than an electron, but lighter than a proton, that acted as the carrier, the mediator of this strong nuclear force.
He called it the meson.
Yes, it was a purely theoretical prediction based on mathematical reasoning.
And the persistence paid off.
It did. His theory was published in 1935, but it took years for experimental confirmation. Finally, in 1947, a particle matching his description, the pion, a type of meson, was discovered in cosmic rays,
Vindicating his theory.
and leading to his Nobel Prize 2 years later. But the significance went beyond just the physics.
How so?
Winning the Nobel, especially so soon after World War II, was hugely important for Japan and for Asian science generally. It helped reintegrate Japan into the international scientific community.
So it was a scientific breakthrough, but also a moment of cultural bridging.
Very much so. Yukawa became a symbol of scientific achievement and helped forge new pathways for collaboration. His persistence was in the deep theoretical work, but also in representing a new era of global science.
He showed how that focused theoretical persistence could also have these broader diplomatic and cultural ripples.
Precisely. Pushing the boundaries of knowledge and also building bridges between cultures.
So as we wrap up this deep dive, looking back at all these stories, Galileo defying the authorities with his telescope, Newton seeing the universal in the everyday, Curie breaking barriers,
Fermi navigating the atomic age, Hawking reaching for the cosmos against all odds, Yukawa predicting unseen particles.
there's this incredibly powerful common thread, isn't there? It's persistence, fueled by this deep, innate curiosity.
Unyielding curiosity, and a willingness to challenge what's known, even when it's difficult or dangerous.
They really remind us that pushing the frontiers of knowledge often takes more than just intellect. It takes courage, resilience.
Yeah, each story highlights a different facet. Galileo, persistence of truth against dogma.
Newton, persistence of synthesis, weaving ideas together.
Marie Curie, persistence of courage against societal and physical barriers.
Fermi, persistence of application and responsibility.
Stephen Hawking,
Ruh.
persistence of intellect over physical limitation.
And Yukawa, persistence of theory and collaboration, bridging cultures.
It's a rich tapestry of human endeavor.
So the final thought for you listening today, as we look at the frontiers we face now, things like dark matter, quantum computing, AI, climate change,
Big challenges, big unknowns.
ask yourself, what are the really important questions worth pursuing now? And maybe more importantly, what lengths are you willing to go to help find the answers?
It's a good question to ponder.
Let these stories, this history of persistence, enrich your own thinking and maybe spark some of that same curiosity. Thanks for joining us on this deep dive.